Hello, geometry. For Mr. Fry, I'm looking at what we were doing in class. I'm not going to go over much of this because I think most of you have this. I want to get to the homework, but in case you missed this stuff, this is how we came about the formula of 180 times quantity of n minus 2. It's because that there's a difference of 2 whenever we talk about the number of sides and the number of triangles within a polygon. And we understood that, all triangles from our last unit, the sum of all the interior angles always equal 180, no matter what triangle you're looking at. And so if you have a 4-sided figure, that's 360, a 5-sided figure, that's 540, and so on. So you could pause this and get all these down. So there you see a pattern there. Ends up we come up with this, the number of sides, or I'm sorry, the sum of the interior angles. The sum of the interior angles equals 180 times n being the number of sides minus 2. So we had a few problems here that we did. 1, 2, 3, 4. You could pause those and get those. You could see where we plugged in those numbers and just figure those out. Once again, that was in class. You should all have that. All sides angles are congruent. We're talking about a regular polygon. And here we have some information about finding interior angles. And so then we started messing with exterior angles. And all you have to do is take 180 minus the interior and you get the exterior. And when you started to do that, taking the interior minus 180 minus the interior, you'll get the exterior. When you add up all the exterior angles on any polygon, it's always going to equal 360. 360 is a circle, So yeah, it means you went around the whole polygon. So 360. So we can conclude that all polygons exterior angles, some of them are the sum of all the exterior angles are 360. You did this in class today. You could do 8 and 10 on your own, but so what is the measure of each exterior angle of a regular hexagon? Well, we'll use this formula, and we could just take 360 divided by 6, and you'd get 60 degrees. That's the measure of each of those. Now we could go ahead and get the measure of each individual interior angle by taking 180 minus 60, and you get 120. So you could use this formula. It's a lot easier than this one. When you're looking for the interior, you could just find the exterior first and just take 180 minus that. Number 9, if the exterior angle of a regular polygon measures 12, how many sides does that polygon have? Well, that would be 360 over n equals 12. So I would multiply both sides by n, and you get 360 equals 12n, and then when you divide both sides by 12 to get n by itself, so 360 divided by 12, you'd get 30. Now to the homework. Okay, so this is the formula for the sum of the interior angle measures. Sum of the exterior angle measures would be 360, and equals the number of sides of the shape. So the interior angle measure of a regular polygon, you'd use this and just divide by the number of sides. For the exterior angle measures of a rectangular or a regular polygon, that's going to be 360 divided by n, and the number of sides of a regular polygon just is represented by n. I guess that's what you put there. And I wasn't sure what they're asking about there, but let me do the odd ones for you. So what is the sum of the measures of the interior angles of a pentagon? Use this formula, plug in your 5, figure it out, and you get 540 degrees. Put that little degree mark there, I guess. What is the measure of each interior angle of a regular octagon? Well, I use the exterior angle formula because it's a lot easier. So 360 divided by 8 octagon, I get 45, and I just take 180 minus 45, and I get 135. That was easier. Or you could do this. You could use this formula, okay? That's up here. Take 180, put it in your calculator, 8 minus 2 times 8 minus 2 divided by 8, and you'll get 135 also. Okay, number 5. 5 angles of a hexagon measure this, and this. Okay, what is the measure of the 6th angle? So first of all, a hexagon 6, the the sum of the angles is going to be 720. So I just took this all to equal 720. Now you could, use algebra. What that is. You could use algebra and add all these up and have it plus x, and then just subtract that, and you'll get 134. Or what I did, I put on my calculator 720, and I subtracted 95, 139, 104, 129, and 119, and I got 134. Okay. Number 7, the sum of the interior angles of a polygon is 3,960. How many sides does the polygon have? Well, I set this formula equal to that, and then I just solved for n. So I took this divided by 180, and I got 24. That's going to be a 24-sided figure. For number 9, what is the measure of each exterior angle of a regular 20gon? I use the exterior angle because that's what they're asking for. So 360 divided by 20, that equals 18. And that makes sense. It's going to be a real small angle because it's going to be almost a circle. It's going to be a real slight angle on those exteriors. Number 11, if the interior angle of a regular polygon measures 108, how many sides does that polygon have? Well, I set all of this, the regular polygon formula, set to 108. Then I solved for n. I got n by itself on one side. And so I had to take negative 360 divided by negative 72, and I got 5. For number 13, find the value of x. First of all, I had to notice that this was a heptagon, and I used this formula to figure out that this was the sum of all of these should be 900. Then I just took 900 and I started subtracting 90, 150, 142, 136, 140, and 148. Just subtracted all those. And I got x equaled 94. Okay. For 15, I'm going to take all these, and I'm just going to add them up to equal 360. You should know by now, four-sided figure from yesterday. Four-sided figure is going to be 360, sum of the interior angles. You could have figured it out by using, this formula right here, and just put in 4 minus 2, so 180 times 2 is 360. Just add all these together, combine your like terms, isolate the variable, and I got x equals 9. So with that being said, 9 sides, I plugged this back in, and it would be 79 degrees. I plugged this back in for B, and it would be 79 degrees B. Number 17, find the value of x. So you have all of these. Remember, the sum of all of the exterior angles are going to equal what? 360. So I just combine my like terms, isolate the variable, and solve for x, and I get 12. So the value of x in this is 12. I didn't have to find any specific angle. I could just plug this 12 into any of these and find each of those angles and add them up, and they would be 360, but we don't need to do that, so I won't. Good luck.